decreasing functions. So we're going to start with talking about intervals, and then we'll talk about interval notation, and then we will talk about what intervals give us an increasing function and a decreasing function, and then we'll also identify some one-to-one functions and what those are, and then we're going to talk about what are monotonic functions. Get a review on what a closed and open interval are. Closed interval is going to be a segment that includes both endpoints, and it's going to be represented with square brackets. So if it's between 2 and 5, you're going to have 2, 5, but around the 2 and the 5 are going to be square brackets. If you have an open interval, that's the one that's going to not include the endpoints, and it's going to be represented with parentheses. So for this segment, it looks like it's between -2 and 1. Since you're including the endpoints, you've got filled in dots, that's going to be a closed interval. The inequality is that x is between -2 and 1, but it could be equal to -2 and 1. So we're going to go ahead and use the or equal to inequality symbols. And then for our interval notation, since we're including the endpoints, we're going to use square brackets. And it's going to be between -2 and 1. Let's try another one. This looks like it's between 1 and 4, but it's not including the endpoint, so it's open. And our inequality is going to be written 1 is less than x, which is less than 4. Notice that I used the less than because it doesn't include 1 and 4. And then our interval notation is going to be parentheses 1, 4. So make sure that you don't get confused. This is not a point 1, 4. We're talking about an interval notation between 1 and 4. So type of interval here, one's closed and one's open. So this is we're going to call this half open. We're going to be positive and say it's half open instead of half closed, half open. So our inequality is that it can include 0, but it can't include 3. So the less than between 0 and x is going to be less than or equal to, but it's only going to be less than from x to 3. And then our interval notation, we're going to have a square bracket around the 0 because that's closed, but a parentheses around the 3 because that's open. It looks like we're going from -2 and it's going all the way past 4, so onwards forever. So we're going to use infinity to represent that. So we're going from -2, which is closed, to infinity. And so since we can't close around infinity, that's going to be a parentheses to show that that's open going that way. So one-to-one correspondence is something that happens when every x is paired exactly with one y. So remember, in order to be a function, your x can't repeat. However, we can have different x's going to different y's. That's okay. But if you want to be one-to-one, every x can only be with one y. So let's look at the function f here, which is 1, 7, 2, 5, 3, 5, and 4, 6. And if we look at our circle mapping, where we match our domain with our range, we can see that this is a function. Every x value goes to exactly one y value. However, if you look, 2 and 3 are going to the same y value. They're both going to 5. Now, this is legal in order for it to be a function. However, it's not one-to-one because they're sharing the same y, so they're not supposed to share. So f is a function, but it's not one-to-one. If you have two y values, the x's that get those y values have to be equal. So if f of a equals f of b, then that means a has to be equal to b. Let's look at this mapping for function g. If you look at those ordered pairs, you notice that every x only goes to one y, so that makes it a function, and then none of the x's share a y either, so that means that function g is one-to-one. All right, let's talk about what is called an increasing function. This is where if you have an x value that's less than another x value, so x1 is less than x2, that if you were to plug those in, then your f of x1 has to be less than f of x2. Now, decreasing is exactly the opposite. If you have x1 is less than x2 and you were to plug those into your function, then your first y should be greater than your second y, and that would be a decreasing function. So here's an increasing function. So notice here's x1. Let's say x1 is -1 and x2 is +1, right? So x1 is -1, x2 is +1. So your y value at x1 is less than the y value at x2. So x1 is less than x2 and y1 is less than y2. So y1 is less than y2. So that makes this an increasing function. So here we have x1 is less than x2, but y1 is greater than y2. So that means it's decreasing. Here's another example of a decreasing function. A function that is increasing or increasing over its entire domain or decreasing over its entire domain is called a strictly monotonic. So it's never constant. It's always going to be increasing or always going to be decreasing. It's never going straight. So it's called strictly monotonic. A little different than monotonic. So strictly is it's always, but a monotonic can actually be constant over part of its domain. And if it's constant, that means it's going to either be non-decreasing or non-increasing. So let's take a look at what those look like. So non-decreasing means that it can be an increasing function, but it can also be constant at some points. So again, it looks like the definition almost looks exactly like it is for a increasing. So x1 is less than x2, which means y1 is less than or y2, but we have this less than or equal to, which means that we can be a constant function at some points. It could be y1 could be equal to y2 at some points. So that means it's non-decreasing. So it's increasing, but it's also non-decreasing. Non-increasing looks like a definition for decreasing, but again, it can be monotonic, so it can be constant or it can be equal at some parts. Let's look at this. This is an increasing function, but we can also say it's non-decreasing because it still could be equal to. So for this one is not increasing. Okay, so it's not increasing because we have a part here that's constant. Okay, so it's not increasing, but it's still non-decreasing because the definition of non-decreasing means that it could be equal to at certain parts, where it is right here, it's equal at this part. All right, go ahead and try some problems on your own.